In this video, we are going to do these 1, 2, 3, 4, 5, 6, 7, 8 questions from the chapter limits. And majorly we will be applying, they are based on this identity standard limits called e raised to the power x minus 1 over x is equal to 1. And we'll also be applying sine x over x for limit x tends to 0 is equal to 1. Plus, I can see that we'll be also using some trigonometric identities. So let's begin with the first question. In this question, we have to evaluate this function for limit x tending to 0. And for doing so, we are going to apply this standard limit, that is e raised to the power x minus 1 over x. I can see we have a sin x also. That means there will be one more standard limit that will be used is what? Sin x over x is equal to 1 for limit x tend to 0. The first thing that we will do is to break this, this function. So what I can write, let's say we have first limit x tending to 0. Can I write e raised to the power 3 plus x as e raised to the power 3 into e raised to the power x, right? Applying laws of exponent in the reverse order. And then we have minus sine x. This is minus sine x. We can write e raised to the power 3 first and then minus sine x. That whole divided by x. Now, in the next step, what we are going to do is to take e raised to the power 3 as common. You can see that e raised to the power 3 is common. So if I take e raised to the power 3 as common, that's outside a bracket. What we get inside here is e raised to the power x minus 1, right? And I can divide it by x. Now I'm applying a separate limit for this. That is limit x tending to 0. This is sine x over x. So I divided x individually. Now check from here. This can be written as what? 1 using this standard limit. So we'll have here e raised to the power x into 1 and minus this again by using sandwich formula will give result to give you 1 again. So we can say that it is e raised to the power x into 1 is e raised to the power x minus 1. So this should be the answer for this question. The question here is to evaluate this function for limit x tending to pi by 6. So what we are going to do is to apply trigonometric identities over here. And for that, we have to divide the numerator and denominator by 2. So first I'll write limit x tends to pi by 6. Now I'm going to multiply and divide it by 2. Let's say I multiplied by 2 and I'm now dividing by 2. So this is root 3 when divided by 2 is this. And then it is sine x minus, again, is 1 divided by 2 and then cos x. So this is cos x and this whole divided by x minus pi over 6. Now check what we can write root 3 by 2. That I can write this as what? Cos pi by 6 and this as sine pi by 6. So this is limit x tending to pi by 6. 2 is there outside and then inside a bracket we have, as I said, we are going to write this root 3 by 2 as cos pi by 6 and this is sine x minus, and sine half is what? Sine pi by 6 into cos x. That whole divided by x minus pi by 6. Now check what you can see, figure out here that we have sine a cos, sine a cos b minus cos a sine b, right? Just by changing the order. So that is sine a minus b. So let's say limit x tending to pi by 6. Outside we have 2, which you can write outside the limit. That's okay to write. And then over here you can see this is sine a cos b minus cos a sine b, sine a minus b. So sine a minus b. B is this, right? Okay. And that whole divided by x minus pi by 6. Now what next we can do here is to replace the limit here. So we are going to put x minus pi by 6 as say y. So here y tends to 0 as x tends to pi by 6. So now the limit has changed. We have y. So there is 2 outside. that you have to keep in mind, right? Say we have 2 outside, and the limit over here, as I said, it is going to change. This is limit x tending to, sorry, y tending to 0, and this is sine, replacing this by y, so it's sine y over y. So you know that this is going to be 1. So finally it's 2 into 1, that is equal to 2. So this should be the answer for this question. In this question, we have to evaluate this function for limit x tend to 0. And for that, we are going to use this standard limit as e raised to the power x minus 1 over x is equal to 1. So what we are going to do here, let's say if I first write limit x tends to 0, first I'll be writing this e raised to the power minus x as 1 over e raised to the power x. That's what we can write. So it becomes e raised to the power x plus 1 over e raised to the power x minus 2, and that divided by x square. So this is limit x tend to 0. What in case if I take LCM? So the LCM is e raised to the power x. On multiplying these two, right? This can be written as e raised to the power x into e raised to the power x is e raised to the power x square plus 1 minus 2 times e raised to the power x. So this is limit x tends to 0. Now you can figure out that this is actually forming an identity, right? This is a square, this is b square, and minus 2 into a into b, right? So this way I can write this as what? You can write this as e raised to the power x minus 1 whole square. And over the denominator, okay, there is one thing I missed. This was 1 over x square. And I can write this x square first and then multiplied by e raised to the power x. So I can put a separate limit for this, right? Or let me show you the actual working. So this is what we got by rearranging. Now we'll put two separate limits. Limit x tends to 0, one for e raised to the power x minus 1 over x the whole square, and the other limit x tends to 0, 1 over e raised to the power x. Now check, by applying this limit over here, we'll get what? This as 1 square. This is 1 square, and that multiplied by 1 over e raised to the power 0 is what? 1. So 1 multiplied by 1 by 1, which is equal to 1. So we'll say that 1 is the answer for this question. In this question, we have to evaluate this function for limit x tend to 0, and we are going to use the standard limit as e raised to the power x minus 1 over x is equal to 1. Now what we are going to do here is to rewrite this to frame this identity. So this is e raised to the power bx. I subtracted 1 from here. You see, I subtracted 1 from here, and I'm going to add 1 also in the numerator. Now check here, I added 1 over here. That whole divided by x. Now this is limit x tends to 0. With rearrangement, I can write this is e raised to the power bx over minus 1 over x, and taking minus common from here, I'll get what? E raised to the power ax. Now this will become minus 1, right? Because we have taken minus common, right? So I can write this properly. This is taking minus common, we'll get e raised to the power ax minus 1, and that divided by x. Now, in order to make that identity, what I can do, I can write over here multiplying and dividing by b, right? So I writing multiplied and divided by b. And over here, I'll multiply it by a. So now applying the limits separately. Limit x tend to 0, that means bx and ax will tend to 0. So I can write bx tend to 0, and b, let's say if I write b outside, let's write over here only. So this is b, and this is e raised to the power bx minus 1 over bx, and applying a separate limit over here, this time limit ax tends to 0. As x tends to 0, ax tends to 0. So this is a, and this is e raised to the power ax minus 1, that divided by ax. So what you can see that from here, I can say on applying limit over here, we are going to get 1. And similarly, we are going to apply limit over here. That also results to give you 1. So what we'll get over here? We'll get b multiplied by 1 minus a multiplied by 1. So we'll get this answer as b minus a. In this question, we have to evaluate this limit. And this is e raised to the power x minus e raised to the power minus x over sine x. And the standard limit we will be using is this: e raised to the power x minus 1 over x is equal to 1. Another is for sandwich formula. So let's begin with the working of this question. First, I'll be writing this is limit x tends to 0. What I can write e raised to the power minus x as e raised to the power 1 over e raised to the power x, that divided by sine x. Later I can multiply these two, right, by taking LCM. If I take LCM, that's going to be what? E raised to the power x, right, into e raised to the power x. Same basis multiplied, powers added. So I can write that e raised to the power 2x minus 1. And this divided by 1 over this multiplied by sin x, because it is divided by sin x, right? So the same as multiplied by 1 over sin x, right? Next, I'm going to rewrite this to frame the identity. I'll write, first I'm rearranging it. Let me write on first this as sin x, and then we have 1 over e raised to the power x as it is. Now to frame the identity, I'll multiply it by 2x, and I divide it by multiplying and dividing by 2x. So what we are going to get? So for the first part, I'm going to apply the limit, separate limit, as x tends to 0, so 2x also tends to 0. But before that, I'm going to write this 2 outside. So what I'll do, I have written this 2 outside. So this is limit x tend to 0, so implies 2x also tend to 0. And this is e raised to the power 2x minus 1 over 2x. That's this part. We are left with x over here. So for this, let's say if I place a multiply sign, limit x tending to 0, this is x over sine x. And finally, another limit for e raised to the power x, 1 over e raised to the power x. So what we are going to get over here is, for this I'm going to get 1 by applying the limit. So this is 2. For this, using sandwich formula, it's 1. And what is 1 over e raised to the power 0? We know any number raised to the power 0 is 1. So e raised to the power 0 is 1. So 1 upon 1 is 1 only. This is 1. So answer is 2. We'll get 2 as the answer for this. In this question, we have to evaluate this function, and what I can see that to solve this, we'll be applying the limit. One is e raised to the power x minus 1, and other is this sin x over x is equal to 1. Further, we'll also be applying 1 minus cos x as 2 sine square x by 2. So this is limit x tending to 0. The first thing we are going to do is to rewrite this, and this can be written as what? Applying the laws of exponent. So I can write this as what? E raised to the power 2 into e raised to the power x minus e raised to the power 2. This, there is an x also, and that divided by 1 minus cos x is what? 2 sine square x over 2. Now we can take out this common, and what is that common over here? I said e raised to the power 2. E raised to the power 2 when taken out common, and since it is independent of x, we can write this as outside the limit also. Now check, we are left with e raised to the power x minus 1, and this is x. So we know that we need an x over here. So if I divide by x, I should multiply it by x square. That's why x become x square. And below we have 2 times sine square x over 2. Now what next? And I missed the limit, as there is a limit here, right? X tends to 0. So e square, which is outside, the limit, and this is limit x tending to 0. This is e raised to the power x minus 1 over x. And I'll place a separate limit, right, for the other part. So this is limit x tending to 0. This is x square over 2 times sine square x over 2. So you can see from here that we need to divide it by, we need an x by 2 whole square over here. So I divided and I'm going to multiply over here. That is x square by 2 is same as x square over 4. So things x square and x square get cancelled and this is cancelled by 2 times. So now see in the next part, this will give you 1. So I'll write this as 1 multiplied. This will again give you 1 square, which is 1 square is 1. So this is, let me write on, this is 1 and 1 over 1 square like this. And we have a half over here. This is half from here, right? And this is not e raised to the power x. This is e raised to the power 2. So what do we get? E raised to the power 2. And this is reciprocal of half is what? 2. So final answer will be 2 times e raised to the power 2 should be the answer for this question. In this question, we have to evaluate this function, and here the limit is x tends to pi by 2. So what we are going to do here is to change the limit over here by substitution. So we can write, say put cos x is equal to say h. So what you can see from here that h tends to 0 as x tends to pi by 2, right? This is because cos pi by 2, cos 90 is 0. Now, after substitution, the limit will change. So the limit now is h tending to 0, e raised to the power, replacing cos x with h. So e raised to the power h minus 1 over h, right? And now using the standard limit, that is for limit x tends to 0, e raised to the power x minus 1 over x is 1. So we can write this is equal to 1. And that is what we have to do in this question. The question here is to evaluate this function for limit x tends to 0, and for that we'll be applying the standard limit, that is e raised to the power x minus 1 over x equals to 1. So over here what we are going to do, let's say this is limit x tending to 0, and we are going to divide this numerator and denominator with e raised to the power sine x. So this is e raised to the power x minus e raised to the power sine x, and I'm going to divide and multiply by e raised to the power sine x. So e raised to the power sine x, and this also e raised to the power sine x divided, then I have to multiply with e raised to the power sine x. And then we had the whole denominator as what? This whole as x minus sine x. Now next step is what? This is limit x tends to 0. What you can see that applying laws of exponent over here, right? Applying the laws of exponent on this part, what we are going to get is e raised to the power x minus sine x. And this will get cancelled to give you 1 over here, and that divided by what? X minus sine x. Let's place separate limit for the other part. Limit x tends to 0, e raised to the power sine x. Now we need to do some substitution over here, and for substitution what we are doing, e raised to the power, not e raised to the power, x minus sine x as y. So you can figure out that y tends to 0 as x tends to 0, because this is 0, sine 0 is 0, so that's why 0 minus 0 is 0, right? So after substitution, what we are going to get is limit. Now this time limit will change as y tends to 0, and this is e raised to the power y minus 1 over y. And here we can apply the limit, right? On applying limit, we are going to get what? E raised to the power sine 0, that is 0. Any number raised to the power 0 is 1. And this, for this part, applying the standard limit over here, what we are going to get is 1, right? This is going to give you 1, and this is any number raised to the power 0 is 1. So 1 into 1 is 1. So we'll get 1 as the answer for this.